All right, so I know that the recent assignment has been giving a lot of people some difficulty, so I'm going to go over how I would go through a couple of these problems on Khan Academy. So it's finding zeros of polynomials. So we're looking to see the x-intercepts, but also any imaginary solutions we might have. This assignment focuses on you just finding out how many times do we physically cross the x-axis, and it doesn't concern itself with imaginary solutions. I want you to know them, but just so you know what the assignment's asking for, it cares about the real solutions. So you don't actually have to go and solve all the way through if you know something is going to be imaginary. You can just let it go, just so you know. So what we're going to do for this particular problem, you want to look and see if there's anything that will fit into every single term here. So we have 4 different terms, all different degrees. So I do notice that there's an x in each of them. We do want to find the largest possible factor that we can fit into all of them. So we're actually going to take out x squared. So I'm going to start with that. I'm factoring out x squared. I do apologize for my really bad handwriting because I'm writing with a mouse, so it's just going to be sloppy. I don't know what else I can do, but I'll try to make it legible at least. All right, so we're going to go x squared, and then to get back to x to the 6th, I have to then multiply by x to the 4th. So that's where that's coming from. Hopefully this part makes sense to you already because we've practiced this a lot. So x squared to get to the 5th, I'll have to multiply by x to the 3rd, and then for negative 2x cubed, I'll just multiply by negative 2x. X times x squared will get me back to x cubed. And then negative 6x squared, I will only need to multiply by negative 6. So there I factored out x squared. Now what we need to do is group. So we're going to group these two, and then we're going to group these two. I'm sorry, it's hard to read again. So I'm going to start with this x squared and just keep it outside, but I'm kind of ignoring it for right now. What I'm doing is I'm going to deal with my stuff in the green. So x to the 4th and 3x to the 3rd have what in common? The highest factor I can get is x to the 3rd power, so I'm factoring that out. So I'm just dealing with what's in the green between x to the 4th and 3x to the 3rd right now. I'm not worried about anything else. I'm remembering to write my x squared, but I'm not going to try to think about it multiplying right now. That's too much going on. So x to the 3rd is what I'm factoring. To get back to x to the 4th, I have to multiply by another x. To get 3x to the 3rd, I multiply by 3. And it's positive, so I'll say plus 3. All right, so we're good. We factored that part. Now let's focus on the red group. So negative 2x minus 6, what's common to both of those terms? The largest possible number I can get, that would be negative 2. So I'm going to take out negative 2. To get back to negative 2x, I need to multiply by x. To get back to negative 6, I need to multiply by positive 3. All right, so we just grouped, and what we're looking for here is we really want these two terms in the parentheses, that x plus 3 and x plus 3, to match exactly. And they do in this case, so we did it right. So what I'm going to do now is rewrite this whole thing simplified as I can. So I'm bringing down my x squared. X to the 3rd and negative 2 are both multiplying by x plus 3. This is confusing to a lot of people. So just trust me on this one. Since they're both multiplying by x plus 3, we can group them together and say, well, this is just the same as x cubed minus 2, the whole thing being multiplied by x plus 3. Okay, so this whole thing in purple right here is equivalent to the previous line. So what I want to do now, it's set to p of x right now, so that means my output. So I'm putting in all these x's and I get out an answer. What I want to solve for, what I'm interested in, is how many times that this function crosses the x-axis. So that means that y is set to 0. So I'm not interested in how much it goes up or down. I want to know from left to right, where does this cross? So I'm setting this whole thing equal to 0. From the zero product property, I know anything that multiplies to, 0 must come from a product that was originally 0. So we're just going to set each factor equal to 0, and we will see what our solutions are. So what if x squared equals 0? Then we take the square root. The square root in this case only has one solution, and that is 0. So that's the only number where a square root or a fourth root or a sixth root or any even root would only have one solution. So that's the only time. Otherwise you have plus or minus. So the square root of 4 plus or minus 2. Those are two solutions. In this case we just have one, x is 0. Let's go to x cubed minus 2. And don't get freaked out by the cube part of it. It's going to be okay. We can still solve. So I'm going to add 2 to each side. So plus 2 plus 2. And I'm just going to write 0 plus 2, that equals 2. Now for this, just like we would square root, I want a cube root. So what number times itself 3 times equals 2? That's what I want to know. For this guy, I would just leave it as the cube root of 2 and just know that that is a number, but since it's going to be such a weird decimal, let's just leave it like that. But that is a solution, and it's going to be pretty close to 1, but definitely not as big as 2. All right, our last solution is x plus 3 equals 0. So that one's a little bit easier. So x plus 3 means that if I subtract 3 from both sides, x equals negative 3. Okay, so we have how many solutions? 1, 2, 3. And the question is, are all of them real solutions? In this case, all of them are real. So we took a cube root, and sometimes we might think, oh, maybe we'll get an imaginary number if we do the cube root of a negative. But no, it's totally fine. So cube root or a fifth root or a seventh root, any odd root will only have one solution. For example, negative 2 times negative 2 times negative 2 would still get me to negative 8. So if I cube root negative 8, I get back to negative 2. Positive 2 is not a solution. So I only have one answer. So for this one, when I cube rooted 2, I only have one answer. So we do have 3 total times where we cross the x-axis, because 0 is definitely on the graph, cube root of 2 is on the graph, it's a weird number, but it's there, and negative 3 is definitely on my graph. So all 3 of those I can graph just on the Cartesian plane, not the complex plane. So those are 3 distinct solutions. Now we want to know what is the value of our biggest x-intercept. So I'm thinking, okay, the largest, so even though 3 is bigger than 0, I'm thinking in terms of negatives versus positives. Negative 3 is definitely smaller than 0. But the cube root of 2 is going to be bigger than 0, because if you think about 0 times 0 times 0, that's 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So we're definitely going to be between 1 and 2. And it's going to be pretty close to 1. So 0 will be less than 1. This is going to be like 1.1 something. So we know that this answer, x equals the cube root of 2, is actually the one they want us to give. And don't be freaked out by that. It's totally okay. You're doing it right. So just hit cube root and 2, and you're done. Good job. We can look at another one, just in case people need a little bit of extra help. So sometimes people will look at this and they think, I don't know how to do this. Ms. Schwartz didn't do one that looked like this in class. This is just already partially factored for you. So you have x plus 3 could equal 0, right? So we're just going to say, all right, I already have one of my solutions, which is great. So x plus 3 could be 0. So that means x equals negative 3 is one of my solutions. Okay. Now we can focus on this trinomial here, we've done these a lot. We know how to factor this, so we're just trying to think, do we have two numbers that will add up to 6 and then multiply to 9? Oh, yeah, that's x plus 3 and x plus 3. All right, so what you end up getting is x plus 3. And notice that there is an x plus 3 here. So if this factors to x plus 3 times x plus 3, and we have another x plus 3, that means this has actually been cubed. So in the end, it's as simple as that. And if you want to go ahead and solve, you could do cube root, and you'll get the same answer of x equals -3. So you don't even have to do that much work. You just know that it's going to be the same solution as x plus 3 equals 0. So how many distinct real roots do we have? Even though this is cubed, we only have one solution. Since they're all the same number being multiplied by themselves, when I set it equal to 0, I'm only going to get one answer. So I just have one, and the only one I have is -3. So that is my answer.